Hi, my name is Zoe Weissman. I'm from Parkland, Florida, and my project is testing phytochemicals for anti-nociceptive effects in both female and male Drosophila melanogaster in order to discover a natural painkiller and reduce bias in the drug industry. My project is all about non-biased, non-addictive painkillers. I was inspired to do my project after reading an article about the bias against women in medicine. Essentially, there's a false idea in medicine that females are harder to work with due to their hormones. Even though this has been disproven, a majority of clinical trial organisms are actually male. Because of this, drugs can have detrimental effects against women and still go unnoticed. I thought this was a serious issue that not many people were talking about, so I decided to focus on it for my project. I also wanted to focus on discovering natural, non-addictive painkillers because I didn't want to contribute to the growing opioid epidemic in our country. Hence, I sought out to find a natural, non-addictive painkiller that wasn't biased against women or men. I decided to use 3 plant-based chemicals: salicin, which comes from the bark of the willow tree, cinnamic acid, which comes from cinnamon, and caffeine. In order to complete my project, I used 3 sub-experiments called assays. My first assay was called the von Frey assay. Basically, I poked larvae with a special type of filament called the von Frey filament and looked for a reaction. If they curled up or thrashed after the poke, it meant that they felt the pain. And if they didn't react, it meant that they didn't feel any pain, which was the ideal reaction. Another assay I used was the heat plate assay, where I would heat larvae up on a heat plate and stop at the temperature that they reacted at. Higher temperatures correlated with less pain felt, which again was the end goal. Finally, I conducted the phototaxis assay. Basically, flies naturally want to fly upwards and towards sources of light. So I put them in a glass chamber with a hot metal ring at the middle, and then I let them fly up. If they weren't able to fly past the ring, it meant that they felt the heat from the ring and didn't want to fly any further. However, if they were able to go past the ring, it meant that the medicine worked and they weren't able to feel any pain. After conducting my 3 assays, I found that salicin worked best for 2 out of the 3 sub-experiments, but cinnamic acid worked best for the phototaxis sub-experiment. This basically means that both salicin and cinnamic acid are valid candidates for developing a non-addictive painkiller that isn't biased against females or males. Although there was a slight bias against males in all phytochemicals, this was likely because of the biological difference between men and women when perceiving pain. This project can have significant implications on not only the drug industry, but also the opioid crisis. First of all, this can lead the way towards more non-biased medicines, and salicin and cinnamic acid can be used in future studies to see whether or not different dosages could have better effects. Eventually, these chemicals can be produced into medicines for the market that are not only non-addictive, but also not biased against women or men. This is important because the majority of chronic pain patients are actually women, yet most of these drugs are usually tested on men. Evidently, this would be groundbreaking. Another reason my project is significant is because it helps find a cure to our country's opioid crisis. Focusing on non-addictive painkillers is important in a world where we aren't focusing on alternatives, but rather direct solutions to the opioid crisis. Although these are important, we also need to find other drugs that we can prescribe to patients instead of just constantly giving them addictive opioids.